Now let us see the definition of these standard units in terms of indestructible things. So let us see meter. So the meter is the length of the path travelled by light in vacuum during a time interval of 1 by 299, 792, 458 part of 1 second. So this is very small time because speed of light is very high. So how do we define meter? Suppose this is light is going. So we take a very small time 1 by 299, 792 by 792 458 part of 1 second, and the distance travelled by light in this time is called 1 meter. Since speed of light cannot change and light will always be there, so this is a non-destructible source of this unit. So meter cannot be changed. Now for kilogram. The kilogram is equal to the mass of international prototype of kilogram. So there is a one standard prototype of kilogram, a platinum iridium alloy cylinder. So a cylinder made of platinum iridium, which is kept at International Bureau of Weights and Measures at Sevres near Paris. So this is near Paris, France. So this is standard. This is from 1889. But just a year before, that means in 2019, there was a new definition of kilogram. But we will not discuss that definition. We will discuss some another definition, which is, since we know this cylinder is destructible, if there is an earthquake or there is some kind of natural calamity, this will be destroyed. So we need some standard which is universal. So now we know meter, 1 meter. So once we know 1 meter, we can divide it into smaller parts. Okay. So what we do, so now once meter is known, we know centimeter. Okay. So this is 1 centimeter by 1 centimeter by 1 centimeter. So what is this? 1 centimeter cube. So we make a cube of 1 centimeter. So this is 1 centimeter cube. Now if we take 1000 centimeter cube, because meter cannot be destroyed, so we know centimeter. If we take 1000 centimeter cube, that means a cubic box which has side equal to 10 centimeter. 10 centimeter. So 10 into 10, 100 into 10,000 centimeter cube. So volume of this cube is 1000 centimeter cube, and we fill water in this cube at 4 degrees centigrade. At 4 degrees centigrade, we fill this with water. So water at 1000 centimeter cube water at 4 degrees centigrade. So weight of that water is equal to 1000 gram or 1 kg. Please remember, this is only at 4 degrees centigrade. Only at 4 degrees centigrade. Because below 4 degrees centigrade, that means 3 to 1 degree centigrade, the mass will be less. Above 4 degrees centigrade, again mass will be less. So this is precisely at 4 degrees centigrade. So mass of 1000 centimeter cube of water at 4 degrees centigrade is 1 kilogram. So again, water is indestructible, and meter we have defined, this is also indestructible. So in this way we define a kilogram in indestructible manner. Now second, what is second? The second is the duration of 9,192,631,770 periods of the radiation corresponding to transition between the two hyperfine levels of ground state of cesium atom. So what is the in common language? So we have taken an atom, cesium atom, okay, cesium 133. So this atom we have taken. So around 9 billion. So let us say 9 billion. So this atom vibrates 9 billion times. When these atoms vibrate 9 billion 192,631,770 times, that time is called a second. So this atom vibrates about 9 billion times in 1 second. This is the precise number. So what we do, we know this is one vibration. So it starts from here, comes back to this. One vibration, two vibration, three vibrations. So when it vibrates around 9 billion times, that time period is called 1 second. Again, the atom will always be there. So this is also an indestructible source. Now ampere. What is ampere? The ampere is the constant current which is maintained in two straight parallel conductors of infinite length of negligible cross section placed 1 meter apart in vacuum would produce between these conductors a force equal to 2 into 10 to power 7 Newton per meter of length. So what is the meaning of this? Suppose we have two wires. These wires are very long. These wires are very long. That means these are infinitely long. And their area, cross-sectional area. What is cross-sectional area? Suppose we have a wire like this. So wire is always circular, you know. So this circular area is called cross-sectional area. So this wire can be very lengthy and this circular area is called cross-sectional area. So cross-sectional area is very less, negligible. That means wires are very thin. Now some current is flowing in these wires. Okay, some current is flowing, I and I. Now how can we say that these currents are 1 ampere? So two parallel wires, these are parallel. These are very long, infinitely long. Cross sectional area is negligible, that means very less. Wires are very thin. Now these are kept 1 meter apart. These are at 1 meter. Now if this wire 1 apply a force of 2 into 10 to power minus 7 Newton per meter. So that means if we take 1 meter length of this wire, 1 meter length of this wire, 1 meter of length of this wire. So every 1 meter length of this wire will put a force of 2 into 10 to the power minus 7 Newton on this wire, or we can say wire 2 is putting same force on this wire, then current in both these wires are 1 ampere. So in this way we define 1 ampere. So if the current between these wires, let us understand in reverse way. So we have two long wires which are 1 meter apart. Distance between them is 1 meter. Now current flowing in them is 1 ampere and 1 ampere. Okay. Since they are 1 meter apart and infinitely long, cross sectional area is nil, very less. So this wire will put a force 2 into 10 to power minus 7 Newton per meter of length. Per meter of length. This is only for 1 meter of length. Per meter force on this wire, and this wire put same force on this wire. So then we exactly know current is flowing 1 ampere. If suppose this current is 2 ampere, then this force will be high. Then this wire will put more force on this. If this current is more than 1 ampere, if this is less than 1 ampere, this will put less force. So in this way we calculate that current flowing in the wires is 1 ampere. Now we learn about ampere. Now next is Kelvin. Temperature Kelvin. What is Kelvin? The Kelvin is a fraction of 1 by 273.16 of thermodynamic temperature of triple point of water. So what is triple point of water? So first let us understand triple point. Triple point. Okay. So we have ice, and when we see this ice, so there is some liquid on this ice and vapor also coming out of this ice. We have already seen there is ice and some water on this ice, and vapor is coming out of this ice. So all three things we see simultaneously, and that temperature on which all three things are there is called triple point, because three things are there, triple point. This is at 0 degree Celsius, and in Kelvin we say it 273.16 Kelvin. So triple point is at 273.16 Kelvin. If we divide this triple point temperature 273.16 divided by same number, so what we get? 1 Kelvin. Okay, so this way we get 1 Kelvin. So Kelvin is this 273.16 part of the temperature at triple point, and triple point is when ice, vapor and water all coexist simultaneously. What is mole? Mole, the mole is amount of substance of a system. Mole is amount of a substance of system which contains as many elementary entities as there are in 0.012 kilogram of carbon 12. Suppose we take carbon 12, C12 and 12 gram of this, and we start counting how many carbon atoms are there. So we get a number 6.023 into 10 to power 23 atoms. So these many numbers. So if we take anything, let us say atoms, molecules or anything equal to this number 6.023 into 10 to power 23, number of that, so that is called 1 mole of that thing. Suppose we take oxygen molecule, not oxygen atom but oxygen molecule, and we take this many atoms of that, so mass of that is called 1 mole. Mass of that is called 1 mole. Now last thing is candela. Candela is a measurement for luminous intensity, that means how much light is there. The candela is the luminous intensity in a given direction, this is in a particular direction, of a source that emits monochromatic radiation. So what is the meaning of monochromatic? That means single color. Single color, let it be blue or any radiation, monochromatic, that is called monochromatic, and they have given frequency 540 into 10 to power 12 hertz. Since frequency is given, this is already monochromatic, so frequency is not varying. So some radiation which has this frequency and has a radiant intensity of, in that direction, 1 upon 683 watt per steradian. So again, what is one candela? One candela is that luminous intensity, that means its strongness of light. So that much luminous intensity in a given direction of a source that emits only monochromatic radiation of this frequency, that means a light of this frequency, which has a radiant intensity of 1 by 683 watt per steradian. So this much intensity, 683 watt per steradian. We have already learned what is a steradian. So this much intensity is 1 by 683 watt per steradian, that is called 1 candela.